Assalamu alaikum, dear students. How are you? Hope you all are fine by the grace of Almighty Allah. I'm also fine. So, dear students of Standard 10, welcome back to my physics class. Dear students, you know I'm taking chapter 10 from my physics book. I have started already this chapter, and the name of the chapter is static electricity. Today I'm going to explain some topics from this chapter, and those are electroscope and Coulomb's law. So let's start the class. At first, I am to make you clear what is electroscope. Yes, electroscope is a device which is used to detect the presence of charge and to detect the nature of the, to determine the nature of the charge. So this is the structure of the electroscope. There is a metal disc, brass disc, which is connected with a metal rod, and the other end of the metal rod there are two leaves that is made of gold. It can also be made by using other light metals like aluminum or any other metal can be used which are light, and this rod is inserted through the non-conducting material, that is cork, and the whole system is enclosed in a glass jar. As the apparatus is kept inside a glass jar, the humidity and the wind cannot damage the instrument. Now I will show you how to charge the electroscope. But before showing that, look here. This is the real picture of electroscope. Electroscope can be charged either positively or negatively. Look, for doing that, you have to take one glass rod. You know, if glass rod is wrapped with silk cloth, then what happens? You know, silk cloth has more electron affinity than that of the glass rod. So that silk cloth will be negatively charged and glass rod will be positively charged. So if we take a glass rod, if the glass rod touches the metal disc of the electroscope, some charge will immediately go to the disc. As the disc is connected with the rod and with the leaves, the charge will spread everywhere. When similar charges appear in the gold leaves, the leaves will repel each other. Due to the presence of charge in the electroscope, thin metal leaves move away from each other and repulse each other and create a gap. Look here, in this picture there is a little gap between the leaves, but here the gap is increased due to the similar charge appeared in the two leaves. Similarly, you can do this, that means you can here the electroscope is charged positively, but you can charge the electroscope negatively by using a comb. If the comb is wrapped with flannel cloths, you know, comb will take the electron from the flannel cloth. As a result, the comb becomes negatively charged. So if the comb touches the disc, metal disc, then that charge will go towards the metal disc, and from the metal disc the charge will be spreaded all over. That means to spreading towards the gold leaves, and as the same charge appear in the two leaves, so they will repel each other. Detection of existence of electric charge. So detection of existence of electric charge. To determine the presence of charge in any body, the body may be brought to an uncharged, sorry dear student, here it will be uncharged, not unchanged, uncharged electroscope. If the two leaves move away from each other, then it is understood that there is an existence of charge in the body. But if they don't move away from each other, then it is understood that the body has no charge. So look here, this is an electroscope which is in neutral condition, where the leaves, where there is no gap between the leaves. But when the ebonite rod is touching the metal disc, ebonite rod which is negatively charged, then what happens? The negative charge will spread everywhere. As a result, there will be negative charges in the two leaves and the gap is created. Then after then if we remove this ebonite rod, the electroscope will be charged with negative charge. So here is the electroscope is charged by conduction process. Now I will show you a video which will make you more clear. The gold leaf electroscope. There is a brass disc. You know the structure. The gold leaf electroscope consists of a brass rod with a brass disc at its top and with the two gold leaves at the other end. Look. This is the glass jar. The rod is inserted through a rubber or plastic stopper into a glass container. The tin foil inside and the wooden base makes the instrument more effective. The gold leaf electroscope is used to detect and measure the charge on a body. The body to be tested is touched to the brass disc of an uncharged electroscope. If the body is uncharged, the leaves of the electroscope diverge. The amount of divergence of the leaves is a measure of the amount of charge on the body. To define the nature of the charge, for this it is first necessary to charge the electroscope positively or negatively. This is done by touching the brass disc of the electroscope with a positively or negatively charged body. The leaves acquire the same charge as on the charged body and diverge. Let us assume that the electroscope is negatively charged. Now, bring the body to be tested close to the brass disc of the electroscope. If the divergence of the leaves increases, it has the same charge as the electroscope. The object has the same charge as the electroscope. Here the object has the opposite charge as the electroscope. If the divergence of the leaves decreases, it has the opposite charge as on the electroscope. That is positive in this case. So I think electroscope is clear to you by after seeing the video. Now I will explain another topic, that is Coulomb's law. So Coulomb's law quantifies the amount of electrostatic force that two charged objects exert on each other, which causes an attraction or repulsion between them. You know, two positive charges will repel each other, two negative charges will repel each other, whereas one positive and negative charge will attract each other. So Coulomb law states about the electrostatic force between two charged objects that exerts on each other, either attractive or repulsive. So look, what is Coulomb's law? We know that the charges of opposite nature attract each other and the charges of same nature repel each other. The force of attraction or repulsion between the two charges depends on quantity of charges, distance between two charges, the nature of the medium between the two charges. Scientist Coulomb states the law about the force of attraction or repulsion between the two charges, and that is called Coulomb's law. You must memorize the statement of Coulomb's law because it can come as your 1-mark question of your creative questions. So look, Q1 is a positively charged object and Q2 is another positively charged object, and they are kept at a distance r between them. So they will they will repel each other as they are of the similar nature. Okay, but if here Q1 is positive and Q2 is negative, then they will attract each other. Okay, so the formula for Coulomb's force equal to K into Q1 Q2 by R square. So suppose two charges Q1 and Q2 are at a distance d from each other, then if the force of attraction or repulsion between these two charges is F, then according to Coulomb's law, F is proportional to Q1 Q2 by R square. So if two charges Q1 and Q2 are placed at a distance d or r from each other, then the force of attraction is directly proportional to the product of the charge and inversely proportional to the square of the distance. You have to remember it. So if we remove this proportional sign, here we have to take one constant. So we can take constant C, or also this constant is used as K in some other book. So both C and K is applicable. So F equal to C into Q1 Q2 by R square. So this is Coulomb force, electrostatic force. The formula of this electrostatic force can be found out. The value of electrostatic force can be found out by using this formula, where C is a constant called Coulomb's constant, and the value of C is 9 into 9, 10 to the power 9 Newton meter square per Coulomb square. It is given in your book. So here unit of charge is what? Coulomb. The unit of charge is Coulomb according to scientist name. So the symbol should be in capital letter. Coulomb is a derived unit. Coulomb is defined from ampere. If 1 ampere current flows through a conductor for 1 second, then the amount of charge that passes through any cross section of the conductor is called 1 Coulomb. You must memorize these definitions. That means what do you mean by 1 Coulomb, or what do you mean by 10 Coulomb? It can also come as your B number question. Okay, so you must make a note. So this is the formula for finding out the electrostatic force between two charges, either attractive or repulsive. So F equal to C into Q1 Q2 by R square, where Q1 is the charge of one object and Q2 is the charge of another object, and R is the distance between them. The closer two charges are, the stronger the force between them, because F is inversely proportional to the square of the distance. So the less will be the distance between the two charges, the stronger will be the force between them. So the formula for Coulomb's law, you know, F equal to K. I have already told you, you can use here K or C. Any symbol can be used. F equal to K into Q1 Q2 by D square, or if you take the distance R, so here you can also take R square. So from this formula you can find out the value of D. D equal to what? K into Q1 Q2 by F. Then the value of Q1 F D square by K K2, and value of Q2 F D square by K Q1. So you must write down this formula in your physics copy, and you will require this for solving creative questions. So dear students, today up to this, in the next content I will show you some mathematical problem. So till then, stay safe and stay strong. Goodbye everybody.